Very good morning, my dear student friends. Yesterday we stopped at the different probability distributions and we noted down their formulae. Okay? Let me recapitulate the same thing or put it in the same this one form. So for continuous variable, the probability distribution used or we are going to use is normal distribution. Okay? It is also called as the Gaussian distribution or natural distribution, like that. So that is given by y1 divided by sigma 2 pi e to the power minus half z square, where z is equal to x minus mu divided by sigma, where mu is mean and sigma is standard deviation. This is for continuous variable. Next one is for discrete variables, we'll be using hypergeometric distribution, or in short form I'll just write HD, hypergeometric distribution. That one is given by the probability that x will take a particular value x is given by n p c x n q c n minus x divided by n c n. What does it mean? Because we know that already, I have explained. NCN means we are going to select n items out of a total number of capital N items. Here it is P is the fraction defective, not percentage, fraction defective. So fraction defective multiplied by the lot size. It will give us the total number of defectives in the lot. If the total number of defectives in the lots are given, there is no problem at all. And what we intend to find out is x. This x is what is the probability of getting those many number of defectives. If P is the fraction defective, then Q is the good number or fraction of good number of items. So try to understand, always P plus Q is equal to 1. That is probability. You can say the probability of happening and probability of not happening. Here, the probability of happening is getting the defective, we denote it by P. Try to understand. Probability of not happening is I am getting a good item here. So this is going to be 1. So this one is Q is the fraction of good items. So NQ is total number of good items present in the lot. And what is this x, n minus x? Because if I find number of defectives as 1 out of a sample of some 5, then the good items I am going to find out in that sample is ultimately it has to be 4. That is what I mean, because n is 5 minus x, well, that is 1 is 4. Is it understood? That means it will have this combination divided by, in total number of ways, how I can select n items out of a total number of the items in the lot. Okay? This is called as hypergeometric distribution. Third, binomial distribution. Again, it will take a particular value x. This is given by NCX, P to the power x, Q to the power n minus x. Fourth one is Poisson distribution. Again, Here I am interested in finding out, it will take a particular value x. This one is given by e to the power minus lambda, lambda to the power x divided by x factorial, where lambda is equal to n into p. That is, it is n is the number of items in the sample, p is again the fraction defective. Okay. E to the power minus lambda, lambda to the power x divided by factorial x. If you will go on inspecting all these things, what is that we are going to get is, here I have mentioned it will take a particular value x. Yes, it is possible because these are applied for discrete variables. Whereas it is, I have given like that, when it is a continuous curve, probability that it will take a particular value, it is going to be 0. Try to understand. Because if it is the continuous variable, it will take a particular value is always 0. Whereas for discrete variable, particular value, yes. That is the distinction. So here I will be using for greater than or equal to type, or less than or equal to type, or between two limits. For example, if I represent it, normal distribution, it behaves like this. A probability that exactly it will take this particular value, that is the area under the curve. So this is the point. Area under the point, we say that it is 0. So it cannot find out. I cannot find out. Now, if it is this point, beyond this, yes, I can find out. Less than this, I can find out. Or it can be between two limits, this limit and this limit, this area I can find out. But exactly this point I cannot find out. Try to understand. That is what is most important for these things. Okay, having delineated all these things, now the question is, which one is to be applied when? The first point is, if it is a continuous variable, there is no way out, but we have to use normal distribution only. Don't bother much about it. If it is continuous variable, we need to use the normal distribution. And to use the normal distribution, we should know what is the value of mean and what is the standard deviation, or we need to calculate it by using the sample or whatever it is. That is what I told you, because in the previous class we were trying to establish how to find out the population or universal parameters by taking the sample. And we established those things. This is how it will become more useful, because when we are going to draw certain inference about the process and other things, we will take the sample and then try to see whether it follows that particular mean and standard deviation. It may not follow exactly that one. It will have certain variations. At how much variation I can allow? It should be natural. That is the crux. That is what we are going to find out, and find out those limits, maximum limits. Within that one, yes, the process is under control. If it is beyond that, the process is out of control. It is as simple as that. Okay. Now, if it is, now that is what I told you, if it is the quality characteristic is a measurable characteristics, and if it is a continuous variable, then we are going to use normal distribution. Suppose if the quality characteristic is judgment or absent and presence of a particular characteristic, or it is a good item or bad item, defective, good, whatever it is. That means if it is of attribute type of the quality characteristics, that means it is counting. That is what we say. Then these three things can be applied, because these are used for attribute type of characteristics. That is what I told you. X number of defectives in a sample of n. X number of defectives in a total number of defectives in the lot, like that. So these three, all these formulae, they are going to use, one thing you try to understand, they are going to use what? Factorial notations. We know what are meant by the factorial notations. But in factorial notations, they have defined what is, for example, 0 factorial. Is it defined? What is the value of 0 factorial? Ah, right, you are right. 1. 0 factorial is 1, it is not 0. 0 factorial, we can find out. Or more than that, anybody has defined 1.5 factorial? No. Anybody has defined minus 1 factorial? No. Or negative values? No. So that is why when we are going to use these three probability distributions, which will make use of the random variable, that random variable is the attribute type of variable. So that when it makes use of the factorial notations, it cannot take negative value or fractional values. They need to be integer values, just because it makes use of, because of the simple reason that it makes use of the factorial notation, and in the factorial I am unable to find out what is the factorial of a fraction value or the factorial of the negative value. Hence all these things, these three distributions are applicable only when it is greater than or equal to 0. That means number of defective, whatever you think, it should be greater than or equal to 0. The moment it is less than that, I cannot use it. Okay, have you understood? Having understood this one, we'll proceed further. Now that is the crux I have said. And yesterday I was also telling, see here, the hypergeometric distribution, it can be used when the lot size is given, okay, fraction defective is given, and ultimately the good number of fraction fraction of good number of items q, because we can know once it is not p plus q equal to 1, because of that one we will know this. And sample size is known, and only the x, it is going to vary, how many defectives it will contain. Okay, try to understand. If these things are given, I am going to make use of hypergeometric distribution. If you look at here, say for example here, what is happening here? Here the n is there, sample size is there, p is there, and of course q is there, okay, but there is no capital there. What does it mean? We don't require. When capital N is not required, when we say that lot size is large. So that itself, it tells us that if the lot size is small, then we are going to make use, and if it is a discrete variable. If the sample size is, lot size is small, then we are going to make use of hypergeometric distribution. And naturally, the sample size will also be small. And when the lot size itself is small, then the sample size is going to be small. Next way, other way around is, no, this lot size is not small, it is large. Then it will become, the calculation by using this one is, it will become more tedious. Hence, it can be approximated by using the binomial distribution. Hypergeometric distribution is approximated by binomial distribution. Even though it gives hypergeometric distribution gives the correct value, we are going to approximate it by using binomial distribution so that we can save the time. Friends, you try to think in 1920s or something like that, when the computers were not developed that time. Now everything becomes simpler. It doesn't make any difference for us. That is why always we talk about now enumeration technique. Total you can take. Whereas in optimization technique and other things earlier which were developed, we went on finding out the branching and binding or something like that. But nowadays, all enumeration, this thing you can done, simulation you can run and then you can select like that because the faster way of computation is possible now. But even then it will consume a lot of time. That is why again they have to resort to these things. Okay. And said that. Now we'll come to this. Now I said n, large or small, lot size. What is large? Is it to be 1 crore, 1 lakh? No, in statistics that is what I mentioned in many of my classes. In statistics, small means less than 50. Don't ask me if it is 49 crore, is it small? Or 51, is it small? We have to make use of our common sense. Okay? Generally, one rule is less than or equal to 50. Okay, fine. If it is greater than 50, you take it as large. Okay, that is the meaning here in case of statistics. So that is why nowhere you find the sample size consisting of more than 50, usually. They will take few samples and then decide. But again, there is a way of taking the sample as well. Okay. So here, it can be used when the lot size is large, then I can approximate it either by using binomial distribution or Poisson distribution. Because both these distributions, they don't have the term containing capital N. Try to understand. Okay, that is why both of them can be used. But it can be accurately measured by binomial distribution if the sample size is, lot size is large and sample size is also large. Your sample size, try to understand. Okay? When the lot size is large, then the sample size may be small or large. So here the sample size is small, lot size is large, sample size is small, and the p-value, it is greater than 0.1. Then I am going to approximate it by using binomial distribution, even though it follows hypergeometric distribution. Try to understand this. Now, if the lot size is large, sample size is large, and p-value tends to 0, less than 0.1, but the sample size multiplied by the fraction defective, if it is a finite value, say around less than or equal to 15, then I am going to use, I will approximate it by Poisson distribution. Then you can ask me, this lot size is large, sample size is large, and p tends to 0, which is also large, NP value is also large, more than 15 or more than 20. What is to be done? Then everything will become just like all the rivers, they are going to join the ocean. Everything can be normalized. You can go to the normal distribution. Have you understood this one? Okay. And now you can observe, if it is to be approximated by the normal distribution, what it requires is mean and standard deviation. That is why we need to find out what is the mean. We need to know what is the mean and standard deviation of binomial distribution as well as Poisson distribution. Okay. Here, in case of binomial distribution, mean value of, if it follows the Poisson distribution, it is mean values given by NP. And the variance is NPQ. And always we know standard deviation is square root of variance, that is NPQ. Square root of NPQ. for binomial distribution. For Poisson distribution, mean and variance both are same. That means mean is also NP, variance is also NP, hence standard deviation here is square root of NP. This is the difference. See, for binomial distribution, it is square root of NPQ, but mean value is NP. In Poisson distribution, it is just square root of NP and mean is NP only. So you calculate these things and substitute over here, then you can find out the probabilities by using the normal distribution that we are approximating at. Because in the long run, ultimately, that is what the power of the central limit theorem says, it is going to end up with natural phenomena only. That is what just I said, all the rivers, they are going to join the ocean. Just like that, all this will culminate into the form of normal distribution. Okay. These are certain basics about it. Okay. Now, we have prepared ourselves for applications of these basic statistical techniques to the real problems. No doubt we can collect the data. But the important thing is what inference we are going to draw out of it. Data in the sense it is in the raw form. What we need to do. Just like that, it will not give us anything. But how the variation is taking, whether the variation is taking place or not, what is happening, if that is to be understood, it has to be information has to be collected and it has to be arranged. And then the meaningful conclusions can be drawn. Okay. So far we have seen this one, how it is easier because large number of data, but we can, if we are able to calculate mean and standard deviation of it, then it is called as descriptive statistics, which will further help us in drawing the inference towards the application. So always we talk about standard deviation and mean for this reason. And already I have given the relationship between sample mean and standard deviation with respect to the population mean or the universal mean and the universal standard deviation. Okay. That is why, because we are going to predict about the inverse by taking the sample. So inverse, that means, that is what I told you, we are going to manufacture so many items. Our process is on. We will end up in producing some 1,000 or 100,000 or 10,000 items. What I will do, I will start the process. After manufacturing some 10 items, I will just see whether is it going as per the intended norms or whatever the specifications I had set up. Then what should I do? I will take the sample and then try to compare. Is it going as per whatever I have planned? Or is it going to deviate from this? That is what I will go on checking. Okay? That is what exactly is being done in the practice. Even now you can take this COVID, the current problem is COVID. What they are going to do? They are going to take the samples. Earlier, the samples were few because we didn't have many those equipments and the laboratories. Now, there are a number of laboratories and the number of equipments. So we'll go on collecting. Why this one has been relaxed now? Because they found out that earlier the recovery rate was small. Now what has happened? The recovery rate is also increased. So it is almost touching 50%. The moment it crosses 50%, then no problem at all. So many people will be in, so many people will be out, then it gets stabilized. That is what, the process is stable or not, that is what I am interested. The same thing happens over here. It is just like maintaining this control charts. But to establish the control charts, what are the things required then? I need to find out what are the limits. How do I establish the limits? If I have to establish the limits, then which quality characteristics I am talking about, that should be known. Okay? The most important thing is, based on the which quality characteristic, if it is non-measurable quality characteristics, then it is very simple, no problem at all. That is called control charts for attributes. Okay? There are two charts depending upon the quality characteristics. So one is control charts for, shall I wipe it out? Okay. Control charts for attributes and control charts for variables. Now I have laid the foundation for both of these things, okay, in the way of these probability distributions or whatever it is. So if we come back to the control chart for variables, before control chart for variables, let us see what is control chart. Control chart is nothing but graphical representation of collected information. What is control chart? Control chart is graphical representation of collected information. Okay? Or it is depiction of collected information in the form of a graph or in the form of a chart. That is what we say. We know the different types of charts. Okay? For example, bar chart, pie chart, something like that. Okay? It is like that. But one more important thing is attached to that one, which is missing over here. See, this is not just a graphical representation of collected information. It is chronological graphical representation of the collected information. It's chronological information. Whatever is there this time, next time, then I am going to draw certain inference. So the chronology is important. If I collect the information and if I go on depicting them in the form according to the time as and when it happens. So I collect certain information. Say, for example, here I will just plot it. Okay? This is some variable. And it has got certain frequency or whatever it is. You can just think about it. Or the value. Okay? One variable and its value. Variable first, second, third, fourth, fifth, sixth. That means this is the time. Fifth sample, fourth sample, third sample. That means I am taking after a certain gap in chronological way. Then in that sample, I will measure the value. That value I will be depicting in the as a y coordinate. So this is according to the time. Try to understand this one, most important. Because first sample, that sample, like that. Say for example, now first sample I will take its mean, I find out to be some value. Next, 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 next. What is happening now? As the time passes, this value, whatever I am connecting, it will go on increasing. But what it should have happened? Irrespective of the time, it should have remained same. It is not happening. That is what it is expected normally. That means I know that the moment it comes to this one, it is increasing. So I know there is something wrong. I'll try to stop the process and try to investigate. And up till what limit I can allow it? That is what I need to fix the limit. This limit, or this limit, like that. Those limits are to be fixed. Okay, these limits, how do we fix? And these values, whatever I am going to fix it here, for variables, whatever it is for variables or attributes. Now we are talking about control chart for variables. That means it is nothing but the chronological graphical representation of the collected information. This collected information is with respect to the variable type of quality characteristic. If this collected information is concerned with attribute type of characteristics, then I am going to use control chart for attributes. Then what are the different types of control charts for variables? Because in both the cases, we are going to represent it. Okay? So, what are the different types of control charts for variables? Okay? There are three. One is, this is control charts for variables. Or in general, I can say control charts can be of two types depending on the type of quality characteristics. This is control charts for variable, and this is control charts for attributes. Control charts for variable, we can draw three. One is X bar control chart, another one is R bar control chart, R control chart, and sigma control chart. Try to understand. It is not X chart, it is X bar chart. This is not R bar, it is R chart. This is sigma chart. R chart means what? Range. Control chart on the ranges. This is sigma means on standard deviation. This is for X bar chart. That means for the mean values. That is what I explained in my previous classes. That is why I took that much of time to explain about those things. Now I don't think, again, I need not have to repeat it. Okay. Now control charts for attributes can be of these types. One is the control charts for fraction defective. Next one is control charts for number of defectives. And next one is because this one is concerned with defectives, or I can classify like this. So better classification would be, I can make it two defectives and defects. Because, my students, friends, it is always better to categorize the things and learn about it. That is what I categorized over here. Earlier, this one I have categorized, and here also I am going to categorize the entire control chart itself. I am categorizing. Even for distributions, I categorize them. So it is a sort of flow chart or whatever it is. Okay. Now this is attributes, defectives or defects. What is a defective? What is the difference between defect and defective? Defective is one item which will contain one or more number of defects. That is classified as a defective item. Understood? Then what is defect? What is defect? Defective, it is collection of number of defects. One or more number of defects. Okay? That is called as classified as a defective. What is a defect then? Defect is one. It is each instance of not meeting a particular specification is called as a defect. Because it is not meeting length specification or breadth specification or width or weight or volume, whatever you can think about it, or surface finish, like that. Okay. Each instance of these things are defects. So, that item can be categorized defective or non-defective based on the defects. So, one is, on total I can maintain on number of defectives or defectives. The another thing is defects. For example, this is one. It might be accepted or rejected based on whether it has got a particular width, whether it is meeting that particular standard or not. Thickness, length, breadth, surface finish, like that, each individual instances. And these number of defects I can pinpoint. For example, surface finish or the blowholes or whatever we can think about it. Okay. Those things I can specify. So here, if it is a defective, classified as defective, then it can be fraction defective or number of defectives. Because these defectives can be, defective items can be expressed as fraction defectives, number of defectives, or number of defectives, two ways. So if it is fraction defective, we call it as P chart. And this one is NP chart. And defects, it can be further classified as C chart or U chart. Okay, these are in general the classification of the control charts. Now, I will be specific now, because whatever I have given up till now about the control charts and the basic things one need to know to understand these things. The prerequisite already I have covered. Now I have given you the definition of control chart and hence the definition of control charts for variables. Because the definition of control chart with respect to type of quality characteristic, namely variable type of characteristics or attribute type of characteristic, we can classify like that. So in general, we need to study about this. So especially for control chart for variables, we will be studying about these three. And when we talk about control chart for attributes, we will be studying about these four charts. Try to understand. Okay, in the subsequent classes. Now let me limit for this topic, for this unit, these things. Okay. But try to understand, I cannot use it independently, X bar chart only, R chart only, sigma chart only. No. In control charts for variables, it has to be used in pair. Okay. It has to be used in pairs. That means X bar chart in conjunction with R chart, or X bar chart in conjunction with sigma chart. I cannot just use X bar chart. I cannot just use R chart. I can use either X bar and R or X bar and sigma. Okay. Now the question comes, when I should go for X bar and R, and when I should go for X bar and sigma. Before that one, already we know what is X bar. Why X bar? I told now why it is not X chart, because not individual, because on the sample means, because several samples I have to take, and in each sample there are number of individual items. Okay, the sample will consist of individual items. Likewise, number of samples I will collect. Okay, and then I can find out sample, the mean of these samples. Okay, individual value, that means individual value I will take and find out the sample mean. Likewise, there are number of samples. So that means there are several means. And out of that one, I will find out its grand mean. Okay, individual sample average, that is what I call it as X bar. For sake of brevity, let us say that the individual values are x1, x2, x3, x4, x5. So its mean I have found out, it should be x1 bar, I will say, divided by 5. These individual values I will find out x1 bar. Okay, what is this? This is the mean of these individual values. Again, these values have got, as I explained, they have got the variation. Actually, they should have been same. It is not same, because natural phenomenon. That is variability. That is what we said. Okay, that is why it is natural, quite natural. So that means these things are not expected things, are they should be same, but they are not same. Hence, how much value I should give, how much variation I should give, how much variation I should allow. That is why that is what the crux on that chart, that limits I am going to fix. How much variation? Variation is inevitable, but how much variation I can tolerate, that is most important. That is what I need to specify. That is called as the limits. These limits I will put, I have to find out and put it on that control chart, which will specifies the limit. Okay, that is what I am trying to, I have to establish that. Before that one I am just telling about this one. These individual values, and they have got the variations. So that means its average value, I am getting it as x1 bar, and here I can measure its spread or the width either in the form of range or sigma. You know, range means the difference between highest and the smallest value, which is very easy. So I can find out the range, I can say it is R1, and sigma, that means x1 minus x1 bar, x1 minus x1 bar whole raised to square plus x2 minus x1 bar whole raised to square, like that, 5 divided by 5, and then take the square root, that will become sigma. That is what is this one we are going to find out. Likewise, I have taken some 5 samples, x2, x3, x4, x5. This sample means I have found out. Now, again there is a variation, because this is the sample mean. These are individual samples. These are the sample means. They have got the variation around what value? They have got the variation around x double bar. X double bar is the mean of the sample means. X1 bar plus X2 bar up to X5 bar divided by 5. That is what I am going to call it as X double bar. So this one is the grand mean of this. Okay, because it has got a variation. Sorry, it has got the central tendency. Around this one it is going to vary. And its variation, it has got the variation or variance which we call it as sigma x bar. For this one. Or I can find out range for this one as well, but it becomes more difficult. The sigma x bar, we can find out. That is more authentic, because one more thing, crux I will tell you. When do you go for range and when to go for sigma values? We can resort it to ranges when the number of individual values, they are less. Less means what? Well, my friends, in engineering, we need not have to talk about less or more or this thing, that thing. No. We need to be quantitatively able to tell. Less means how much? That is what I told you. Large. Lot size is large. That is the difference between an engineer and somebody else. Large means no. Large, here more than 50, large. Yes, agree. Likewise, here individual samples, this 1, 2, 3, 4, 5, 6, 7, like that. Individually, I can take 5, 6, 10, 15, 20, 30, 40, like that. So usually, if it is around 10, then we'll be calculating the range. If it is more than 10, or even we can allow this one up to 15. If it is more than 15, then we will think about the sigma values. What is one? If the individual numbers are more, then I will talk about sigma. If they are less, I will talk about R. But in any case, if central limit theorem is to be applied, the individual values cannot be less than 4. Okay? But usually 5 is preferred. So that means it becomes easier for me. So that I need not have to calculate, go for sigma value. I can use R. And at the same time, the things will become easier for calculation of the average value. Very easy it becomes. How? Let me show you. Let me say that there are some 5 values, because 5 samples, why I am connecting is 5 values. So let me say that every time I find out, I will take a shaft, I measure its the dimension, it is, say diameter is 5 mm first time, second time again 5, third time again 5, fourth time again 5, fifth time again 5. Okay, 5 times I have measured. Now I want to find out the values, average value. That means this is X1, X2, X3, X4, X5. So X1 bar, I am going to find out. This has to be divided by 5. This is going to be what? 25 by 5. This is equal to 5. Average value is 5. Okay, when I have taken the sample, I'll find out. How did I find out this average value? I added it up, divided by 5. Okay, I'll show you another way. If the sample size is 5, this is what we call it as sample size, is 5. Now what I will do is, I will add up all those things and multiply it by 2. What is one? I add up all these things. 5 plus 5 plus 5 plus 5 plus 5, 25. I multiply it by 2. That will become 50. Okay? Dot, decimal point. Now, to find out its mean, that is what I will do. I will add up it and multiply it by 2. Move this digit, decimal point, to the left by 1 place. That means what? 5.0. What is that? 5.0 will give me the average value. That is why most of the time we resort to the sample size of 5. And also I mentioned that even in nature, even if we look at our hands, it has given 5 fingers, left, right, whatever it is. If these things are more or less, the person cannot work efficient. That is what it means. That is the natural thing. And even if you look at the span of control, there also it will be like how many hierarchies have to be there, that span of control or whatever it is. And in each hierarchy, how many people I can control. It is advisable to have 5, 4 or 5. So just try to think. The span of, that is what we call it as the span of control. Okay? That is why the significance of 5, I told you. Because it helps in 2 things. One is finding the average value becomes much more easier because you just add up and then move that one by 1 decimal digit towards the left instead of making these calculations. No, not necessary. Okay? That is how it can be done. And I am going to compare this one. That is what I told you. Here I am not going to find out the value of sigma. I will find out the value of R. What is R value here? Highest is 5, lowest is also 5, 0. Or if it were like this, that is 5 plus 4, 15. Instead of this one, okay, we will make it 4. Okay. 22 divided by 5. Average value, how I have to find out? 22 by 5. So it might work out to be something around 4.4. Okay. It will work out around 4.4. Instead of that one, what I will do? 5 plus 4, 9, 13, 17, 22. 22 equal to how much? Into 2, 44. And if I want to find out its average, what I will do for 44? Now this is the digit, I will move it here, 4.4, I can say. Just imagine. Okay? Average value I can find out like this, or I can divide it by 5, and again I am going to find it out to be equal to 4.5, 4.4. Both are same. Now what is the range here? What is the highest value? 5. Lowest value? 4. Range is 5 minus 4, 1. Right? But if you have to find out the standard deviation for this one, then 4.4, 5 minus 4.4 whole raised to square plus 4 minus 4.4 whole raised to square plus like this and divide by n and then take the square root. That will give the sigma. Instead of that one, we can go for range. Understood? Okay. That is why mostly we will be using this X bar chart, because likewise I will take number of samples, because these are number of sample and each sample will consist of individual values. That is what I call it as the subgroup size. One is subgroup, another one is subgroup size. Subgroup size is the sample size. Okay? That is denoted by n. Subgroup size is denoted by n. And how many subgroups are there? 1, 2, 3, 4, 5. These are denoted by m. Try to understand. Okay? In statistics, n represents the lot size. Small n represents the sample size, and m represent the subgroup numbers, number of subgroups, not subgroup number of subgroups. seldom we talk about individual value in statistics. We always talk about the collected values. That is why grouping. Why? In that case, it follows the normal distribution. Why? Because of the central limit theorem, whatever it has specified, it says like that. Okay, have you understood this thing? These things you need to keep in your mind. Okay. Now I have given you what is the definition of control chart, what are the different types of control charts, and what are the control charts for variables, and what it will consist of. Now, X bar chart means what? Because we know like that, we can find out for this one, X1 is like this, X2, another some X6 for this thing. That is what I have told yesterday. And then here I will find out the range for this. Let it be R1, R2, R3, R4, R5, or I can find out the standard deviation itself, that is sigma, that I can call it as sigma 1, sigma 2, sigma 3, sigma 4, sigma 5. These are average values. What is one? Average, range, these things. If I find the average of these averages, I call it as X double bar. If I find average of these ranges, I will call it as R bar. If I find out the averages of these standard deviation, I will denote it by sigma bar. Now, these two things are to be used in conjunction. Only X double bar value or R bar or sigma bar value, no. They should be used in conjunction. That means this variation, how do I find out? By either R or sigma. So this means what? X bar chart, what it says? It will just say whether the mean value is within the limits or not. Only mean value it will talk about. But those values may not have the consistency. What this one? They may not have the consistency. So what it will delineate is, yes, these average values, they are in a different samples. This is first sample, second sample, third, fourth, fifth. Among that means, is there any variation among the samples? Variation from this sample to this one, this sample to this one, this sample to this one. So that is what the X bar chart reveals. But is there any consistency or within the samples? That will be revealed by this range chart or sigma chart. And we require both. We require it should be consistent as well as its mean value should be proper. That is what we should say. Always we talk about it. Average value should be more and it should be consistent. For example, some batsman in cricket, if you consider, if he comes, he hits sometimes 100 and sometimes 0. Can't understand. Then what is his average value? We can talk about one time 100, another time is 0. That is how much average value 50. But another